Are you ready? Let's get started. All right, so the thing I am going to do, the first thing is this. Make sure that everything that has to do with x goes to one side, right? So what I will do is, let me divide the line into two. So the first thing I'm going to do, look at this. I'm going to say that 2 raised to power x is equal to 5 minus x. Simply put, subtracting x from both sides of the equation. So I have this. So at this point, what should I do to also remove everything that has to do with x and its function? So I'm going to divide both sides by 2 raised to power x. So I'm going to divide this side by 2 raised to power x. Also divide this one by 2 raised to power x. So this cancel this, we have 1. And this is going to be equal to 5 minus x divided by 2 raised to power x. So at this point right now, this is going to be the same thing as, let's say, 5 minus x bracket times 1 all over 2 raised to power x. That is what it means. And remember, 1 all over 2 raised to power x is same thing as 2 raised to power minus x. Okay, so I'm going to break it down. Okay, so remember that. So I'm going to have 1, which is going to be equal to 5 minus x in brackets multiplied by 2 raised to power minus x. So you see, everything about x has been pushed to one side of the equation. But remember, I told you we need 2 major mathematical skills, Lambert W function and logarithmic equation. Okay, so that simply means that I need this skill. Look at this. If I have 2, this 2 is still the same thing as saying e raised to power ln 2. Don't distract me, okay? Remember, 2 is equal to e raised to power ln 2. So if I have, let's say, if I have px, you see the same thing going to be e raised to power ln px. So I need this skill, number 1. I also going to need another skill which is called Lambert W function. Lambert W function. So what does this law say? The law says that if you have x, e raised to power e, that if you employ the Lambert W function, it's going to give you x. Let me show you another pattern. If I have ob, e, ob, if you employ the Lambert W function, the answer is going to be what? I'm going to hear you say ob. So whenever you have a particular function, e to the power of that same function, if you employ the Lambert W function, you're going to have that same function. So I don't want us to see it as something very difficult. It's just a pattern. It's just a pattern that has occurred. I'm going to use these two to solve this problem. Now the question should be, how can I construct this equation in order to get it as x e raised to power x? That is the only problem we need to do here. And I'm going to do it, and I'm going to see how I'm going to do it. Now, the next thing I'm going to do, remember, I'm having 5 minus x. So I must also have e 5 minus x. But first, let me bring in 5 minus x here. Therefore, I'm going to multiply both sides by 2 raised to power 5. Also times 2 raised to power 5. Now, as I have done this, this is going to be 32. 2 raised to power 5 is 32, which is equal to 5 minus x. 2, you remember they are the same base. Their powers are going to add. Therefore, I'm going to have 5 minus x. So you see, I have this, I have its power. But this is not e. If these two were to be e, I would have just taken w of both sides to get that. But then, it's not yet. I'm going to do something else. I'm going to bring in it. I will show you what I will do. It's very interesting, actually. So I'm going to do something to this to bring in e. I'm going to say that 32 is equal to, remember what I told you about this, this is going to be 5 minus x, then e ln 2 raised to the power 5 minus x. Remember I told you that if you have 2, is something as e raised to the power ln 2. You know, but people say it doesn't cancel, but people say this cancel this, you have 2 left. So I didn't change 2 raised to the power 5 minus e. I just brought another way to write it. All in the bit for me to just get something like this. This is what I'm looking for. And I'm using this to construct it. So once I did this, remember that if I have something like ln 2 raised to the power x, the answer is going to be what? X ln 2. So that means I'm going to rewrite this. I'm going to have 32 is equal to 5 raised to the power x, 5 minus x, then e. So the one on top is coming to multiply the log. It's a normal power law of a log. So I'm going to have 5 raised to the power, raised to the power 5 minus x ln 2. Okay, you see, it's looking like this. I'm having something here and e and the power of that same thing. But you see what has spoiled it? ln 2 is not here, so it has spoiled it. So what should I do? I'm going to multiply ln on the both sides. So I'm going to have 32 ln 2 is equal to 5 minus x ln 2. That is multiplying it on both sides. Then I'm going to have e 5 minus x ln 2. Of course, I have gotten to that point whereby I have x e raised to the power the same x. But in this case, I'm having 5 minus x ln 2 e to the power of the same thing I have here. I'm having it as power. At that point, I can include what I call the Lambert W function. But I'm going to rewrite this equation. I'm going to write 5 minus x in bracket ln e, in bracket ln 2 e to the power of 5 minus x ln 2, which is equal to 32 ln 2 or ln 2. All right, let me check what I'm doing so far. So at this point, if I bring in W function here, the answer is going to give me x. So if I bring in W function here, everything here, I'm also going to put its W function here. This is going to give me what? What should it give me? It will still give me this same thing as the base. I'm going to have 5 minus x ln 2, which is equal to W 32 ln 2. So at this point, I'm going to open the bracket and make x the subject formula. All right? So I'm going to clean one side of this equation to the board. All right, so remember, I'm not going to complicate anything. I'm just going to open the bracket. So I'm going to have 5 ln 2 minus x ln 2. Just open the bracket with ln 2, which is equal to W 32 ln 2. So I'm going to, if I open the bracket, I'm going to have that x ln 2 is going to be equal to, carry this to this side, bring this here. I'm going to have 5 ln 2 minus W 32 ln 2. So I will divide ln 2 on the both sides. So I will divide by ln 2. And this is going to divide by ln 2. So this cancel this. So I have that x is equal to 5 ln 2 divided by ln 2. So I'm taking this ln 2, breaking the fraction, minus w 32 ln 2 all over ln 2. This cancel this. So I have that x is equal to 5 minus product log or w function of 32 ln 2 all over ln 2. This does not have the capacity to cancel this. Can it? All right, so at this point, I think the right thing to do is to get the calculator that can carry out this function. Maybe most of your scientific calculator cannot carry out this function, but then this is the answer you get in an exponential form whenever you solve a question like this. Have a nice day. Please don't forget to hit the subscribe button, like the video, and share it.